Welcome to my presentation about making Android phones last. My name is Luca Weiss. I'm a software engineer at Fairphone. In my free time, I'm also working on projects such as PostMarketOS and also some other open source projects. And you can find some links here on the slides. So what is Fairphone? Maybe some of you know it. We are a small phone manufacturer based in Amsterdam in the Netherlands. We are building Android phones and some audio accessories also nowadays. And we focus a lot on different aspects of making these more sustainable. So between fair materials, so actually getting better conditions into the supply chain for mining. Then fair factories, so actually improving the conditions of the people who assemble the phones and where all the components are being manufactured. For longevity, we try to make sure that the devices last as long as possible, so both in terms of repairability, but also in terms of the software support that we do. And this is also mostly the part where I'm working on. And then we also have a reuse and recycling focus point there. Yeah, so we've been around for 12 years. We've launched 5 smartphones since then and some audio stuff. And the team I'm working in, which is the software longevity team, we are basically tasked with keeping the Android software up to date and keeping making sure that new Android releases come to the devices. Yes, and all of our devices are based on Qualcomm SoCs so far, except for the very first one. Yes. So what have we done so far as our team? So for the different devices, we are mostly going quite far beyond the lifetime where the SoC vendor supports us. So for example, for Fairphone 2, the first Qualcomm phone that we had, only for Android 5 and 6 were supported by Qualcomm. And then we still did Android 7, 9, and 10 on our own with our own resources. And got them also Google certified and everything to be able to ship them to regular customers. And yeah, it only became end of life, I believe, in the beginning of 2023. So we had more than 7 years of software support for this. And also for the newer phones, we're still maintaining them, all of them, where we're also working on beyond the lifespan, where we are well supported by the SoC manufacturer. Yeah, and also we are trying to open source as much of the code as possible. So also for all of the software builds that we do, for example, for the Android framework space or in the Bionic repository or whatever, any changes we have on top of this, where the base project is an open source project, we also publish the source code for this. So that, for example, also community Android distributions like Lineage.js can easily look at the code and, for example, see what was changed in the audio HAL. Also for clarity, so the software longevity team in Amsterdam, we are maintaining devices mostly after a period of, let's say, 2 years, where our ODM is bringing up the devices and then also maintaining them. So we basically only get the devices once they're already a bit older. Okay, so let's talk about the kernel problems that we kind of face. So for all of the devices that we have received one kernel version from the SoC manufacturer with millions of lines of code changed or added, with a lot of extra code on top of the Android common kernel, so the ACK. For Fairphone 5, so the newest phone, we should actually be receiving a kernel upgrade with an associated baseline update, so the vendor software. So we should actually be getting kernel 6.12 there from upgrading from current 5.4, which will be really nice, but it is the first device where we're getting this. For all the other devices, we've received one kernel version, and that's it. And the most you can really do there is merge, for example, the stable kernel into it. But anything on top of this is just basically a nightmare to do. yeah, so what we've also seen and learned is the ODM basically avoids touching the kernel source code whenever possible. So they do the bare minimum if it's not required by, for example, Android or by BTS, the build test suite, then it is just not done. So for example, LTS updates is not something that they merge in by themselves. And we've also asked them, but yeah, they're very unwilling to do a lot there. Whenever you actually do merge the stable updates, for example, there's a lot of merge conflicts because of changes that were done by the SoC manufacturer on top of the Android common kernel or in the Android common kernel based on the LTS kernel. Yeah, for the 504, our a bit older device already from 2021, we are still on kernel 4.19. But at the very least, there we have from the civil infrastructure platform, we have the super long-term support 4.19, where they are maintaining or aiming or promising to maintain this, I believe, until January 2029. So at least we should be able to get some amount of updates without too much effort into our kernel for that. I wrote here a bit funnily, generic kernel image is coming because so far, I mean, the 504 that we've spent most of the time on right now in the team, there we do not have GKI. It's 4.19 kernel. For the 505, which is 5.4 kernel, it's GKI 1.0. So it's also still this half version of GKI that's not doing too much, let's say, for us in terms of making anything easier. Also, funnily enough, with the upgrade to 6.12, because we don't have an init boots partition on the device, for GKI 2.0, we'll probably also not be able to use like any of the GKI stuff there. Why not just rebase or merge newer kernel versions? We have actually spent quite some time already internally to try and bring up the device, for example, on a newer Qualcomm baseline. So for example, for the 5.4, we tried 5.4 kernel or even a newer version. But while it is possible to bring it up to some degree of booting, so for example, the recovery works well on a newer kernel, but then you quickly hit some problems with, for example, the GPU, where you just have some driver differences between the two versions. And yeah, a lot of the interfaces just changed between also just one LTS version. So it is very difficult to do something there. And also, unfortunately, when you're working on upgrading to a newer, already quite old in upstream terms, kernel version, then also any effort you spend on this, if it doesn't fully succeed this project, then the effort is also just lost. So with upstream work, at least, then you can, if you have one driver working, you can push it upstream, and then it can hopefully also be reused by some other people. So yeah, historically the entire Android tree was built in one Android version. So for example, if you had an Android 9 image, you had an Android 9 source tree, you compiled it and you flashed it to the device and you had Android 9 working. Since a while, there's a thing called Google Requirements Freeze, where then the parts of the software is actually not getting upgraded. So for example, on the 5.4, we get an Android 11 vendor software, and then you can, for example, put an Android 14 system image on top, which sounds nice for not needing to change the vendor software to get a new Android version. But it also means that we're basically stuck with maintaining Android 11, even though we had Android 14 or 15. And because this is already so old, and it is not easy to update this to a new version then. Having Android 11, having Android 11 vendor also means that, for example, implementing newer HALs, so for example, for the flashlight brightness API, which was introduced in Android 12, it is just not possible to add this because the vendor software is in Android 11. So you cannot add a HAL, or at least I'm not aware of a way to add a HAL for Android 12 into Android 11 and get this functionality working then. So even though you're getting new Android versions, basically the vendor parts or anything that depends on HAL versions, you just cannot get, unfortunately. And also, still the Android 11, for example, uses very old compilers and build tools, and maintaining this also means that, for example, if your host OS where you build Android updates, that then you maybe need to do some changes, because on Android 11 at least, I don't know if it's much better on your versions, but at least on Android 11 there's still some implicit dependencies on some host tools, and if you upgrade, for example, E2FS procs to a new version, then the build fails. Yeah. There's also a thing called longevity TRF, which is actually covering the needs for kernel upgrades at least. So with the old one, it was also just one kernel version. With the new one, you actually do get a new kernel version at some point, but still the vendor software is being left on the same version. So the thing with the flashlight brightness API, it's just the same. Yeah, and I would say for phone manufacturers, this is quite a limiting factor, because you just don't have the resources to then get the vendor software into a super much newer version, and you also can't really deviate from this program, because it's what the SoC vendor gives you, and that's what they support us on. And if you deviate from it, then you can't really ask for too much support from them, unfortunately. So for the Android parts, basically, we've tried for the different devices with the different Android version, we've tried different, so when we didn't have SoC vendor support, we tried different baseline sources for it, basically. So either use AOSP directly, or even use LineageOS, for example, or use some version of the Qualcomm system sources. So nowadays, with Phathom 4, we are using the QSSI, so the Qualcomm Single System Image, but it's basically AOSP plus some Qualcomm additions on top. Which are which are needed for some telephony features. But there also then we have the problem that QSSI, at least the ones that the releases we've seen, they're only based on the major releases. So all of the QPRs, so where Android is doing quarterly platform releases, you cannot get them, and you're just also then again bound to whatever the QSSI version is based on. Yeah, and even with the whole GRF stack, so keeping the vendor software stable and keeping Android updated on top of this, there's still some problems where the old HAL versions actually do break in a new system, because, for example, some flag is not really interpreted correctly in a new Android version. It's also understandable Google doesn't have the resources to try to test all of these versions, but then as a phone manufacturer, you're then stuck still with the same code that is broken, and you need to figure out how to fix it. Yeah, and with Android, it's also not really easy to contribute code changes back to it. We have submitted some patches to AOSP Garrett in the past, and most of them either they haven't been merged even after a lot of trying to get people to review it, and sometimes it did get a code review +2, but then nobody did anything else with it. So it's also a bit, for us, it's a bit complicated to know whether Google actually wants smaller bug fixes to be contributed back or not. So now we have some ideas how what things we could contribute to AOSP, but we've already given up a bit, at least for now, because it's very difficult there. So for upgrading Android with old kernel versions, this hasn't really been too much of a problem in the past. For example, the Phathom 2, which was running Linux kernel 3.4, so from 2012 or something, we were able to upgrade this without too many problems to Android 10, and also Android 11 should have been quite possible. But nowadays, Google really likes to use new kernel features, so especially I think in the eBPF stack, they like to use some new features. This then basically means that with kernel version 4.9, which our Phathom 3 device is running, Android 13 is basically the maximum version that we can get to. We have looked into what it would take to get Android 14 running, but there is, and while it is possible to backport some patches to the 4.9 kernel, since the code that is using these eBPF features is actually shipped with the Google Play System updates, so with the mainline modules, we actually don't really have any control whether, or we have little control over testing and actually blocking the release for our devices in case there would be some issue, because we have a, let's say, hacked up kernel version that is not really 4.14, but yeah, has some feature set that actually works with it. And same with kernel version 4.19. Basically, Android 15 is the maximum. With Android 16, there are some checks now that require kernel version 5.4 on your. So they were also then maybe getting stuck with upgrading to new Android versions. Yeah. Yeah, and of course, I mean, it is clear to me and to us that these old kernel versions, especially when they're end of life, which is then when Google is generally dropping support for them, it is not a great idea security-wise, but it is the only way that we have, essentially, without spending an extreme amount of resources on it. Yes. So, but you can of course also run upstream kernel on our devices. Basically, all of our devices have at least some amount of upstream support. But I would say it's mostly for running Android, production-ready Android on it that we can ship to customers. It's just a proof of concept. We can see that it works. We can boot Android on upstream kernel. We can use some open source hardware to boot it. That's no problem. But then a lot of not so small features are missing then. I call them here hidden drivers, because when you first look at the device, you can see the screen is working, or you can boot it up so internal storage is working. But then there's some small bits, for example, these hardware wrapped keys for encryption and some trust zone communication and USB audio offloading, where it is still not supported upstream. They are definitely coming. So I think all of these points that I mentioned here, most of them have some patches on mailing lists, or it's already merged. But still, there's just tiny big things missing. And also for if you actually wanted to get this production ready for us, it also means we cannot really use any of the original hardware abstraction layer, because the kernel interfaces are probably quite different. And also many of the HALs that we have, they are pre-built for us, so we do not have the source code. So we couldn't even modify them to make them work for the new kernel interface. So either then we could shim the kernel interface somehow to make the HAL still work on the upstream kernel, so just shimming the downstream interface. This is available. But yeah, also not a great solution. Yeah, and I mean, what we see in upstream anywhere, I think, is that most devices are generally quite similar, and they can share a lot of code. This would be nice, but yeah, in upstream, code sharing is no problem, but with downstream, everybody's just doing their own work all the time, and there's basically little to no sharing going on. Yeah, so also you can run the feature column on the right side, so the green bits. These are features which are working on upstream Linux with 7.5, so newest phone. Basically, the major points that are not working is audio, which is very annoying, and then some smaller bits. So NFC, I just didn't take a look yet, and haptics is also should be very easy to bring up. But otherwise, at least for simple use cases, so for example, for using it for watching some YouTube on the device, is no problem at all. And you can also use it with different mobile Linux distros, such as PostmarketOS or Mobian. So in summary, I would say there is definitely a lot of progress happening in the whole space. We see the programs like GKI and now GBL and everything else, which are appearing. But then for the devices that we maintain and that we still want to maintain for many more years to come, so I think 7.5 should be maintained at least until 2031, which is still quite a lot of years, and it's currently running kernel 5.4. So and unfortunately, all these let's say older devices they do not get in the fancy new features. So if we wanted to have GPL to get the bootloader to a somewhat more maintainable state instead of just keeping it as it is, this is not really possible, or not really supported, at least. Yeah, so long-term support is actually quite resource intensive. All the things that need to be done for getting an Android image ready to ship to customers. So from Google certification and getting in alignment with operators, and then of course making sure that there's no important bugs for users. This takes quite a lot of time, and from every side there's some pushback always to make the updates come a bit faster. And it's also just a difficult market for small companies like us to invest a lot of resources into fixing some of these issues. So I know if we had a lot of money, we could just pay some other companies and to fix the problems for us. But unfortunately, we are just at a scale where we cannot afford this. So we are trying to walk the line where it is enough to keep the users happy, but not too much that we run out of money. So yeah, but I would say the future is looking bright. I would actually say the longer support cycle is also coming by through EU regulation, and I think some other jurisdictions also have something there. So yeah, at least future devices should have this working quite a bit easier. But then we're still maintaining our existing devices because users are using them. So we want to have the users keep using them. Thank you. And are there any questions?
I wanted to ask if you have some number of how many users are using your Fairphone and still using Fairphone 2, because you said you still want to plan until 2029 for the Fairphone 2. So is it a big user base?
Yeah, so Fairphone 2 is end of life, but it was launched in 2015. So we do have some numbers of how many people are still using our devices with some let's say simple tracking for this. I do not know the numbers right now, but it is definitely quite a bit longer than the industry average of how long people are using a given smartphone. I'm pretty sure you can find the numbers in our impact report that we have on the website. The one for 2024 was actually released, I think, just a few weeks ago, so should be quite up-to-date numbers on how long actually people are using our phones according to the numbers that we can find for us.
Thank you.
Any other questions?
So what kind of patches to AOSP are pending review, like small bug fixes or new features, or
So the bulk of the patches for especially Android framework stuff is operator-specific customization. So, for example, some operator wants their network name to be shown in the status bar, and some operators want the Wi-Fi calling toggle to be named a bit different, or shown or not shown. So there's a lot of patches regarding this, and then also some smaller. So let's say Fairphone added customization that we actually want to add is very little. But then for the operators, we have a number of patches where I think some of the things should also just be just put into AOSP, for example, just as a carrier config, because I don't think that these operators want this, for example, the network name just to be shown on our devices, but on all of the devices. So I think there are also a lot of code duplicate, or a lot of work could be avoided by having this somewhere common, and then the operator is saying to, for example, to Google, like, hey, I want this to be shown, and then this would be added for all of the devices. Any more questions? Then thank you.